Hello, this is a recording to help us use the quadratic graphing template to graph a standard form quadratic. Let's use the function f of x equals x squared plus 2x minus 8. And before we begin, it might be helpful to identify our a, b, and c value. So a is the coefficient of x squared, a equals 1, there's an invisible 1 here. B is the coefficient on the x term, so that equals 2. And C equals negative 8 in this problem. We're going to find our x-intercepts first. These are also called roots. And to find our x-intercepts, we are going to set y equal to 0. And f of x represents y. Our answers are going to be ordered pairs. Now, since we said y was 0, what we'll find is in each ordered pair, we'll have a 0 for y. Now, if you have a standard form quadratic and you want to find the x-intercepts, you set it equal to 0, and then what we often use is big X and factoring. So that's what we're going to use on this template. The top of big X is a times c, so that would be this invisible 1 times negative 8. So negative 8 on top. On the bottom, we're going to put b for bottom, so that's our 2. And now we're looking for two factors that multiply to be negative 8 and add to be positive 2. Well, we know we have to have a positive and a negative factor to get negative 8, and that means our factors have to be 4 and 2. 4 times negative 2 is negative 8. 4 minus 2 is 2. Now we're not done. We're going to write this as 0 equals, and instead of writing this equation now, we'll write the factored form, x plus 4, x minus 2. Then we take each factor and set it equal to 0. So we get x plus 4, let me rewrite that. X plus 4 equals 0. X minus 2 equals 0. We use inverse operations, so subtract 4 from each side. So one of our x-intercepts happens at x equals negative 4. The other x-intercept will happen at x equals 2, because we'll add 2 to both sides here, and we'll get x equals 2. I'm going to fill these numbers in to my ordered pairs up here. So I have negative 4, 0, and 2, 0. Then I'm going to come over to my graph, and I'm going to graph these two ordered pairs. I have negative 4, comma 0, and 2, comma 0. All right, the next thing they ask us to find is the y-intercept. If you want to find a y-intercept, you set x equal to 0. Notice that's the opposite of this intercept. So x-intercept, set y equal to 0. Y-intercept, set x equal to 0. That means our ordered pair will be 0, comma something, because the x will be 0. So if I have y, or f of x, equals x squared plus 2x minus 8, and I'm making all the x's 0, I'll get y equals 0 squared plus 2 times 0 minus 8. That's 0 plus 0 minus 8. So y equals just plain old negative 8. There's a shortcut to this. And what the shortcut is that you simply use 0 for x and then c for the y value. 0, comma c, right? Because if this x is 0 and this becomes 0, then all you're going to be left with is this negative 8. Okay, so that's our y-intercept. We have an ordered pair there, 0, negative 8. I'm going to come over to my graph, and I'm going to put a point at 0, negative 8. Now, the next thing they want us to find is our axis of symmetry. We're going to do this mathematically, but I want to point out that you can also usually do it visually. What is exactly in between negative 4 and 2? Because the axis of symmetry is the middle of the parabola. And if we count, we would realize that we're going to have an axis of symmetry that runs right along here at x equals negative 1. But let's do it mathematically because sometimes it's not as easy as the visual. So the axis of symmetry is actually a line, and we notate that with x equals something. There's a formula. X equals negative b over 2a. Now, negative b means negative, and then you fill in whatever b is. And then 2a means 2 times whatever a is. So our b was positive 2. So we have negative, and in parentheses, we have a 2. 2 times a would be 2 times a was 1. That gets us negative 2 over positive 2. By the way, you always have to simplify these. So if I simplify negative 2 over positive 2, I get negative 1. So x equals negative 1. That is our axis of symmetry. And so I'm going to come over here and I'm going to draw my axis of symmetry. And that's going to be a vertical line at x equals negative 1. So what I'm going to do, and most people do it this way, they put a dotted line vertically. Oh, I just did that at negative 2. I just ruined my graph. Uh-oh. They put a line vertically at the axis of symmetry at x equals negative 1. Try to ignore that. Okay. So then the optional method is you add the two roots together and divide by 2 because that helps you find the middle. Remember how I said it would be just right in the middle of negative 4 and 2? Well, if I add negative 4 plus 2 and then divide by 2, I get the middle. That's the midpoint formula. So for the midpoint formula, I do x1 plus x2 divided by 2, where x1 plus x2 are the roots, or the x-intercepts. So that would be negative 4 plus 2 divided by 2. And that gets me negative 2 over 2 equals negative 1. So that's the same answer, it's just the optional method. This is the method, though, that you'll be responsible for on any assessment. So the vertex is the turnaround point on the parabola, right? So our parabola is either going to look like this, or it's going to look like this. And this highest point or this lowest point is what we call the vertex. So the one thing we know about the vertex is it's always on the axis of symmetry. So we already know then that our x value of our vertex is always going to be whatever we already found for negative b over 2a. So I already know that this is negative 1. And then how do I find the second number? Well, I plug in or substitute. If we know x has to be negative 1, then that's actually exactly what our function is for. I'm going to use my function to find f of negative 1. So that's going to equal negative 1 squared plus, let's see, 2x would be 2 times negative 1 minus 8. So negative 1 squared is 1. That's minus 2 minus 8. And these come together to be negative 1 minus 8, negative 9. So my ordered pair is negative 1, negative 9. And that is my vertex. Now here it asks us what's the shape. Well, this is a quadratic because the biggest exponent of x is a 2. So our shape is going to be a parabola. We're concave up, meaning the ends point up, because the a value is positive. So if this had been a negative one, we'd have an upside down parabola. But since this is a positive one, we have a parabola that looks like a U, both ends point up. And then since we're concave up, that means that our vertex is a minimum. It's at the bottom. Okay, so this vertex over here is a minimum value. It's at the bottom. You see, this parabola doesn't really have a maximum value because these little arrows mean that this thing goes on until infinity. So it never maxes out. It just keeps going, but it does have a minimum value, and that happens right here. Okay, wow, table of values. Last thing. So when we're going to create a table of values for a quadratic, when we know the vertex, then we put the vertex in the middle of the table of values. We know our vertex is -1, -9. So in our table of values, we're going to start with -1, -9. We already have that point. Then what other points are we going to put in our table of values? Well, we're going to put the 2 points that come before -1 and the 2 points that come to the right of -1. So what I usually do is I do -1, I work my way up, then it would be 0, 1. If I work my way to the left, -2, -3. And then I need to find all these values. I'll need to find f of -3, f of -2. I don't have to find f of -1. I already did that, -9, f of 0, and f of 1. And to find those, we substitute into our equation. Remember, our original equation was x squared plus 2x minus 8. So for -3, it'll be -3 squared plus 2 times -3 minus 8. So that's going to be 9, positive 9, minus 6, minus 8. 9 minus 6 is 3. 3 minus 8 is -5. So I'll have a point 3, -5 on my parabola. F of -2, that'll be -2 squared plus 2x, so that's 2 times -2 minus 8. -2 squared ends up being positive 4. -2 times positive 2 is -4 minus 8. So that gets me -8, right? Because 4 minus 4 is 0, minus 8. I already know my vertex is -9, 1, -9. And let's see, f of 0, right? So I'm going to plug in a 0. I get 0 squared plus 2 times 0 minus 8. That's 0, 0, and -8. And if you recall, we actually found that point already over here. And then f of -1, or positive 1, I'm sorry. So it would be 1 squared plus 2 times 1 minus 8. That is 1 plus 2 minus 8. 1 plus 2 is 3. Minus 8 is -5. -5. Now, if your vertex is in the middle of your table of values, then what you'll find is that this works its way out with equal values. So -9, and then on both sides of that is a -8. On both sides of that is a -5. Okay, I always still do all my work because that's kind of how I check that I'm doing things correctly. And so let's just graph the points now that we don't have yet. We didn't have -3, -5 yet. So -3, -5. And -2, -8. We did not have that point yet. We already had -1, -9, 0, -8, and the other one is 1, -5. So I have the points of my parabola now, and I'm connecting these using a curve shape. So I'm going to try kind of sketch this for a second in my mind and do the best I can to keep a smooth curve. And then remember, this goes on to infinity. Whoops, I didn't mean to do that there. And let's fix that a little bit. And there's my parabola. Okay, I'm going to zoom out for a minute so you can see all this work at once. Let me adjust things. Zoom out a little bit more here. There we go. Okay, hope this has been helpful.